Tonight on The Buzz, we are looking at the impact of artificial intelligence on media as we talk with industry thought leaders about the current status of AI, where it's used, and how it impacts the work that we do. We start with Phillip Hodgetts, the CEO of Lumberjack System. Phillip is a technologist who is driving the AI discussion in regard to media. Tonight we talk with him about what AI is, how it's used, and what we can expect in the future. Next, Andy Steinbach, physicist and founder of Paradigm Shift AI, talks with us about the new science of AI, machine learning versus deep learning, and how AI is being used today. Next, Sam Bogoch, the CEO of Axle.ai, explains the practical uses of AI in media. He describes how it can be used for speech-to-text transcripts, object, facial, and logo recognition, and tagging footage to allow us to find exactly the section we're looking for. All this plus James DeRuvo with our weekly doddleNEWS update. The Buzz starts now.
Since the dawn of digital filmmaking,
authoritative,
one show serves a worldwide network of media professionals,
current,
uniting industry experts,
production,
filmmakers,
post-production,
and content creators around the planet.
Distribution.
From the media capital of the world in Los Angeles, California, the Digital Production Buzz goes live now.
Welcome to the Digital Production Buzz, the world's longest-running podcast for the creative content industry, covering media production, post-production, and marketing around the world. Hi, my name is Larry Jordan. Almost every day, some emerging facet of artificial intelligence makes the news. Headlines like, "Will robots take your job?" cause all of us concern. In 2013, Oxford University estimated that 47% of all jobs today were at risk of being automated. Reports since then have lowered the number, but while no one questions that automation will have an impact, there is a lot of debate on how much. Tonight, we take a closer look at artificial intelligence in post-production. We talk with three different technologists to help us get a better idea of where AI is being used today and where it's likely to take us in the near future. By the way, if you enjoy The Buzz, please give us a positive rating and review in the iTunes store. We appreciate your support to help us grow our audience. And now it's time for our weekly doddleNEWS update with James DeRuvo. Hello, James, and welcome back.
I'm back and ready to rock.
So what's our lead story this week?
This is like a really sudden breaking news kind of a story. Lexar has decided to drop their plans for XQD media card production and will instead focus on Compact Flash Express. They cited difficulties with Sony and other parties in getting the approval status, so therefore the resurrected media card maker will instead focus on the future with a more 8K-friendly Compact Flash Express card standard. And that's not a bad thing either, because cameras like Canon, Nikon's F-Series, and Panasonic's new S1 camera support Compact Flash Express with a simple firmware update. The cards work in the exact same XQD media card slot.
So what does this mean in real life?
Well, Sony's always been rather proprietary in their thinking, and with XQD being one of the few exceptions. So now I'm wondering if after Lexar closed its doors the first time, then Nikon and Panasonic add new mirrorless cameras that support the XQD format, Sony may have decided just to start dragging their feet in order to just completely control the XQD media market. On the other hand, since Compact Flash can work in those same cameras with that simple firmware update and is up to 8 times faster than XQD for file transfer, perhaps this is just a case of Lexar deciding, let's just move forward and not backward, because we're looking at an 8K future.
All right, that's story number one. What's story number two?
Well, Canon has finally patented an Ibis image stabilization system that will have the DSLR body work in concert with the image stabilization of the Canon lenses to create a more 5-axis kind of image stabilization system. But it could only be for their DSLRs. The description doesn't mention either DSLR or mirrorless camera in the patent application, but the patent drawings feature a DSLR camera and not the EOS R mirrorless design.
So where do you see this fitting in?
Well, knowing the snail's pace conservative nature of Canon, it wouldn't surprise me if this new Ibis technology would make its appearance in a lower-end EOS camera like maybe a 7D or a 6D or maybe even a 5D Mark V before it goes into the EOS R mirrorless system. That's just the way they test out and field test their new emerging technologies. They did it with dual CMOS autofocus as well. But Canon has also said it's focusing its attention on the mirrorless platform, so perhaps a Mark II EOS R mirrorless camera could get the nod. Either way, it's good news for Canon fans.
What does the Ibis system do that a lens stabilizer doesn't?
The Ibis system works in combination. You will have two image stabilization systems. You'll have the system inside the camera body itself, and you will have the image stabilization inside the lens, both working in concert to dampen out any camera movement. It's just a more efficient and effective image stabilization system.
Thank you. James, what other stories you following this week?
Other stories we're following this week: what media cards are best for the EOS R mirrorless camera and the Blackmagic Pocket Cinema Camera 4K. Our friend Heath McKnight returns with a review of Film Convert color grading software. And Panasonic puts out a new GH5 update only a week after its last one. That's what we're working on. What's tonight's show about?
Tonight, we're looking at the impact of artificial intelligence in media. Almost every day I'm seeing new articles on the growing impact of AI on our lives and industry, so it's time to take a closer look.
Well, as long as his name isn't Hal, I think we'll be okay.
And James, where can we go on the web to learn more about these and the other stories you and your team are covering?
All these stories and more can be found at doddleNEWS.com.
And James DeRuvo is the editor-in-chief of DoddleNEWS and joins us every week. I'll talk to you next Thursday.
Have a good weekend.
Here's another website I want to introduce you to, doddleNEWS.com. DoddleNEWS gives you a portal into the broadcast, video, and film industries. It's a leading online resource presenting news, reviews, and products for the film and video industry. DoddleNEWS also offers a resource guide and crew management platform specifically designed for production. These digital call sheets, along with their app, directory, and premium listings, provide in-depth organizational tools for busy production professionals. DoddleNEWS is a part of the Thalo Arts community, a worldwide community of artists, filmmakers, and storytellers. From photography to filmmaking, performing arts to fine arts, and everything in between, Thalo is filled with resources you need to succeed. Whether you want the latest industry news, need to network with other creative professionals, or require state-of-the-art online tools to manage your next project, there's only one place to go: doddleNEWS.com. Phillip Hodgetts is recognized as a leading technologist, as well as the CEO of Lumberjack System. Even better, he's a regular here on The Buzz, where he specializes in explaining new technology. Hello, Phillip. Welcome back.
Hello, Larry.
Phillip, tonight we're looking at artificial intelligence. But before we start talking about AI, we should probably define AI and some other terms I've heard used with it, like machine learning and deep learning. How would you define AI?
Well, artificial intelligence is a nice umbrella term that everyone is locked onto, and I think we immediately go to that, that super science fiction autonomous intelligent machine. Fortunately or unfortunately, we're nowhere near that at the moment, and under that artificial intelligence umbrella are some autonomous machines that can make decisions within a narrow domain. That would be sort of artificial intelligence at proper, I would say. Then there's machine learning, where a particular machine can be trained to make decisions based on very specific parameters, like recognizing a skin cancer or something like that. And then we have the deep learning stuff, where instead of training a machine, we give the machine some sort of challenge and say, hey, now go for it. That's kind of the broad overview. And if we look at a couple of examples of each one, it might help clarify the different ways they fit into the landscape.
Sure.
Artificial intelligence would be something like a self-driving car. It's autonomous, it's able to make decisions, but it's within a limited domain. I would not expect my autonomous car to mow my lawn, for example, because it simply wasn't trained for that. Machine learning is what we've really come to get a lot of benefit from, and machine learning is behind all of the speech-to-text transcription software we benefit from now. It's behind image recognition, sentiment recognition. It's behind Adobe Sensei's color matching in the latest version of Premiere Pro, and automatic ducking in Premiere Rush. It helps you,
and Audition, for that matter.
And Audition, yes. I hadn't caught up on that piece of information. Thank you. And things like predicting which mailbox a particular piece of email might go into in Apple Mail, for example. So that's the application of machine learning. Colorizing. There's a lot of ways that machine learning has been used. And the deep learning is where you give a computer a challenge. So, for example, Google had a model of a humanoid character, bipedal humanoid character, that they gave it an environment that included gravity, and basically said, move forward, be upright. And it just iterated over and over and fell over thousands and thousands and millions of times until it worked out how it could move forward under those conditions. This is only, of course, a stick figure in a computer, but it's a challenge and a lot of machine composition of music is getting its own challenge to get better and better all the time. And sometimes they pit two machines against each other. A facial recognition piece of software is challenged by a facial generating software. One says, is this like a face? And the other says, no, I don't think so. And so they train themselves.
Okay, well, take a breath for a second. If I'm hearing you correctly, I just want to summarize this. If I'm hearing this correctly, AI is an umbrella term, and machine learning is where we are teaching the machine, we meaning some subject matter expert, and deep learning is where the machine is iteratively learning on its own. Have I summarized that accurately?
Lovely summary, yes, exactly precise.
And is there other categories of artificial intelligence aside from how the machine learns, or in other words, what other categories are we going to hear buzzwords about?
I'm not sure I understand the gist of that question, though. Sorry.
That's all right. I'm just curious if I've used two terms that are ways that artificial intelligence is taught to a machine learning and deep learning. But I don't know enough about AI to know if those are the only two categories or if there's other categories as well.
Well, on top of that is the autonomous artificial intelligence. But essentially, you're right. There is machine learning and there is deep learning. There are variations on deep learning, but that's enough detail, I think, for this discussion.
All right. Well, I'm just thinking that AI seems to have burst into our consciousness over the last couple of years, though I'm sure it's been in development for a long time. But what's happened in technology that has suddenly made AI so accessible to everybody?
It was the development of neural networks. Over the long history of artificial intelligence as the umbrella term, there have been many fits and starts to get a little bit of progress and then run into walls. It wasn't until we got neural networks which are able to have feedback mechanisms so they can self-train that the machine learning side of it has become even possible. And out of a different strain of research, the deep learning has come as well. Generally speaking, these are research projects that don't touch most people's lives. We see more the benefit from it at the end of a model being trained and run on our own hardware, on our own systems.
You used a term that I also need to define. You talked about a neural network. What's that?
You know, it's a magic black box that does that. It's a series of interconnected layers that feed to each other, and that has to have the training feedback loop, which is why it needs some sort of it has to be trained. But the neural network just basically guesses what an output, and if it's closer, then it tunes itself to guess more in that direction, And if it's not close to the right output, it tunes itself in the opposite direction. It is possible to track through. I believe a very skilled forensic mathematician can work out exactly how a machine model is making the decisions that it gets trained to make. But basically, it's a black box that once trained just runs.
Is the neural network the hardware? Is it the software that the hardware is running, or is it the data that the computer's being fed?
I really want to say yes to that because it has elements of all of those things. I mean, it is obviously it has a hardware layer because all computers have a hardware layer at some point. But it also is a way of tying things together in software. And without training data, it's probably not going to actually happen. So that training data provides the feedback loop, which is why it's so essential to have not only the data that you want, but also the ranking that you want. So even if it was theoretically possible to generate a machine model that would replicate an edit, where do we find thousands or millions of examples of graded edits that everyone would agree on the grade? That's much more suited to things like recognizing a skin cancer, which has a very precise accuracy to it, or matching color. These are things that we can measure and successfully guide a machine to learn.
Okay, so far we've been talking globally about what AI is, but let's now drill down into media. I mean, we've got Siri and Alexa at the consumer level and extremely sophisticated industrial machine control at the enterprise level. But for the purposes of the buzz, how is AI being used in media today? Largely,
it's what I group under the heading cognitive services. These are things that have been machine models that have already been trained. And as I mentioned earlier, things like speech-to-text, image recognition, sentiment and emotion recognition, entity recognition, logo recognition, these things that can be trained, object detection. These things are very common in not common in asset management systems, but certainly are used in more than one asset management system that offers these. Great Meta offers this service. Axle.ai is another that uses machine learning, these cognitive services, to help find and sort media. And I certainly see that we should have this sort of image search and speech search built into our editing software in the future. Tagging B-roll is nowhere near as fun as it seems like when you think about it.
You've used the word training multiple times, and I've got a picture of you at a whiteboard talking to a computer. What does training actually mean?
Well, you have to teach the machine what you want it to do. I know that sounds very vague, but but for example, because I think it's an easy example. A machine has been trained on millions of radiology scans of images of skin cancers. And they've already been ranked by a radiologist that says this one has no skin cancer, this one has a skin cancer present, this one has it in this location, and so on. So we have this enlarged set of data that describes each image, and we feed each image to the neural network that is the machine that we're going to train, and then it says, well, I'm going to guess that is a cancer in this corner, and it says, no, sorry, try again. And it does. It iteratively tries again and again and again until it gets 95, 96, 97% accuracy, however accurate you can live with. Similarly, you can use, Apple have provided some, we'll have to get back into this in a moment, Core ML frameworks that can do image recognition, but you might want to train it on the particular set of images that you want your app to recognize. So they've done some of the heavy lifting, and you have to train it on the last mile. So we still need this training data and have to train the model. Then we need another set of data to actually test whether we've trained the model accurately and it's not just faking out, cheating on the test, so to speak, and before we can deploy it into the real world.
So in order for a machine to be trained, we have to have an expert that knows what the answers are to say this is the image and this is the answer, and the machine then learns from that over the course of repeating it multiple times.
One way or the other, yes. And if that data set is in a machine readable form, well, that would make it much easier.
So no whiteboard, huh?
No whiteboard. No, not this time.
Your software Lumberjack system integrates AI into its software. How are you using it for your stuff?
Well, I wouldn't, based on our previous discussion, I wouldn't call it AI. I would call it machine learning. We've just completed the integration of speech to text within the software so that you can once you import your event from Final Cut Pro 10, you can choose which clips you send away for transcription, and they're back in a staggering 8 times real time, and in parallel. So, if, for example, if you had 7 or 8 40-minute interviews, they would all be back in about 5 to 6 minutes.
What do you go ahead?
I don't see, but then the next step is to do sentiment extraction and keyword extraction from those transcription data, and that's our next step.
What's the advantage to editors to having this machine language applied to our clips?
Well, it makes everything easy to find. I mean, ultimately, there are 2 parts to doing the role of an editor. One is finding the material, and one is sequencing the material in an aesthetically pleasing, emotionally compelling way. And if you can't find anything in the project, then you're not going to be able to get discoverability. When we first brought transcriptions into Final Cut Pro 10 for those O.J. Simpson documentaries for Patrick Southern, they found that they located footage, or they located sound bites that they would not have otherwise been able to find, because they could search the entire transcript by word and by content, rather than having to have something tagged to be able to find it.
What do you see as the future for machine learning for the medium term? Not future, because that's impossible to predict, but like next year or 2?
I think we're going to find more and more smart assistants, either built into our software or adjunct to our editing software and our workflow processes. I mean, smarter search, smarter findability of assets, that's got to be part of it, smarter color matching, smarter audio tools. A lot of the things that we do as part of our process can be assisted. I like to talk about Steve Jobs and his metaphor of, a man is not the fastest animal on the planet, but a man on a bike is close to the fastest animal on the planet. And I'm thinking, well, with these smart assistants, we're going to be closer to the man on a motorbike. Because, a lot of what gets in the way of people being creative is the organizational aspect. I have friends who have great creative ideas. When it comes down to actually organizing material and finding story in there, they run into this wall, and it becomes almost impossible for them to progress. And I see these tools that help us sort through what we've got and pull out storylines and ideas that we can then build on and apply our creativity to. I think that's the next couple of years.
And Phillip, for people who want to keep track of your thinking and work in this process, where can they go on the web?
PhilipHodgetts.com is my personal playground, and Lumberjack System is where Builder can be found.
Both of those are single word, PhilipHodgetts.com and LumberjackSystem.com. And Phillip Hodgetts is the CEO of Lumberjack System. And Phillip, thanks for joining us today.
It's always my pleasure.
Take care. Bye-bye. Andy Steinbach is a physicist with a PhD from the University of Colorado Boulder. He's led teams developing some of the world's most revolutionary technology, including the world's highest resolution microscopes, novel semiconductor processes, and high-speed optoelectronic devices at companies like NVIDIA, KLA-10 Core, Zeiss, and JDS Uniphase. Most recently, Andy has launched the AI consulting company Paradigm Shift AI, which is dedicated to helping enterprises develop AI and deep learning applications. Hello, Andy. Welcome.
Hi there.
I don't get to talk to physicists very often. You're at the leading edge of making this stuff happen, as opposed to the rest of us who are trying to figure out how to use it after it's been invented. Which brings me to my first question. What got you interested in AI?
I saw that AI was starting to solve problems that were so complicated, you simply never thought that they could be solved. So I asked myself why, and as a physicist, what I realized is it was solving one of the most difficult problems that we face in physics. Imagine that you have a system where you have a complicated computer network and you're trying to detect cybersecurity attacks. That's just an example. There might be 1,000 different variables that allow you to potentially detect when a packet is an attack or not an attack. But the problem is that when you have 1,000 variables, you get something called the combinatorial explosion. That's if those variables take all the values they can have, you very quickly get sort of an infinity of combinations. what I realized is that as neural networks started to finally come into their own and really started working around about 2012, that they were actually solving this problem. Did you ever wonder why people's brains, you might have heard that the synapses in the brain fire at 5 milliseconds. That's 200 times a second. Well, that's really slow. If you think of the computer as a big, powerful brain, the question is, why is it powerful? Because we know that these wonderful chips we have nowadays operate at gigahertz and even faster than gigahertz. So why does the brain work so well when those connections fire thousands or millions of times slower? And it's really two reasons. One is that it takes all the input in parallel, like in vision. These neural networks take all the information in parallel. But the second big reason is they process the information through a series of steps. And the way that these algorithms that a neural network essentially executes, it's designed as sort of a decision tree, like a flow chart, where at every step you eliminate a whole set of decisions in this big combinatorial space, and then you never go back and look at that part of the space again. And so you can imagine a big sort of sphere, and you make the sphere of where your answer could be smaller and smaller, and then eventually get to the right answer. And it happens exponentially quickly when you step through a series of steps. And so long story short, these neural networks finally started working, and they solved this combinatorial explosion, this curse of dimensionality. And so we can finally solve problems that were just simply off the table. And the performance that companies like Google and Facebook are getting, and researchers, demonstrates that they're succeeding. And so it's really a new scientific revolution. And when I saw that, I wanted to get involved.
Well, before we get too deeply into the subject, let's take a step back. How would you define artificial intelligence? And do you consider those two words to be synonymous with machine learning?
At the simpler end of the spectrum, artificial intelligence, you can think of it very simply as framing a problem as a question and answer pair. With machine learning, you need a domain expert to do what's called handcrafting the features, so it's not very scalable. Whereas deep learning will automatically discover or detect these features, and so you do not need domain-specific knowledge in order to make deep learning work really well. So it works better, higher performance, and it works without domain knowledge. So it's scalable. So that's a winning combination for deep learning.
If I were to summarize, could I say that artificial intelligence is the category and a subset of artificial intelligence is machine learning and another subset would be deep learning?
Yeah, absolutely. I think the way to think about it is artificial intelligence is a very general term. People that technically study the topic would say that machine learning is a large class of methods, and deep learning is a specialty class inside of that. So you're absolutely right.
You recently gave the keynote at the Storage Visions conference. What was the topic of your talk?
Artificial intelligence is now a science that's come into its own with some of these technical innovations that I explained earlier. It really is a new science where rather than, again, going back to the fact that with most sciences, you need people that spend essentially their whole life studying a specific domain and they become world experts in it. With deep learning and deep neural networks, you can now take large amounts of data and you can train models to give you answers. So it goes back to this sort of question answering capability. Without having these domain experts, you just feed it all the data in the beginning and it sort of figures out the domain knowledge on its own. And that's really a revolution or paradigm shift in the way that science is able to be done. So data science is really going to be a new science that's sort of on the par of other sciences like physics, chemistry, and biology.
Well, give me some examples.
A good example and an application area that I'm really excited about is so-called IoT. IoT stands for the Internet of Things. Any machine or instrument nowadays, it could be your toaster, it could be an automobile, or it could be some industrial piece of machinery that is in a manufacturing plant, has a bunch of sensors that are typically wired to a computer network, and the sensors spit out data, and they're monitoring all the inner workings of the machine, whatever it is. It turns out that you can take that time data, and you can apply deep learning algorithms, and you can analyze all kinds of things about the state of the machine. I'm particularly interested in the case of what's called generally industrial IoT, big pieces of machinery that you would have in an industrial company or factory. With these industrial IoT deep learning algorithms, you can do predictive maintenance. So in a maintenance cycle, you can say when the tool needs to be maintained. And of course, normally you do it by some preset time period every 2 months. But sometimes it needs to be serviced faster and later, and it can affect the performance of the outcome of the product that it's producing. And so wouldn't it be great to be able to understand where you are in that cycle? And so that's called predictive maintenance. You can also do what's called health monitoring. So many of these complicated industrial tools naturally have failure modes that occur from time to time, or in some cases frequently. And so wouldn't it be great to get an early warning or prediction that something in the operation is looking just a little bit different than normal, and it hasn't affected the performance of the thing or the parts, let's say, that tool is producing, but that it will. And if you could predict that, you could really improve the yield in factories.
Well, that's AI used in a monitoring application. Are there other examples of how AI can enable an enterprise?
Another example that I'm excited about is something called reinforcement learning. So imagine that you're doing this industrial IoT application and you're monitoring some tool, and you can predict that something's going wrong with the tool, and so that you should perhaps take that one offline and service it. So that's what's called predictive intelligence. But even when it's operating normally, wouldn't it be great not to just be able to predict what's going to happen, but to actually optimize the performance of that tool so that you can increase your yield or the performance of your product that it's producing? And so there's a way to do that also with deep learning. And that optimization is called reinforcement learning or deep reinforcement learning. That's a very exciting area. And some of your listeners may have heard that, for example, Google applied that to optimize the power usage of their giant computer data centers. And so they were able to save something like 30% on the cooling power required. So that's a really nice example of a real-world application.
You've talked a lot about AI in high tech, but can AI help us in medicine?
One application in medicine that I'm particularly excited about is something called precision medicine. AI algorithms, for example, can take a look at patient data records. And so one application that I'm working on is EEG, electroencephalogram, which is electrodes on the brain, and you can take a patient and you can diagnose them. For example, are they at risk for depression? Are they at risk for having an epileptic seizure and that kind of thing? And you can classify them as normal or having a problem, which you detect. But wouldn't it be great if you could use those deep learning algorithms on that data to not only be able to tell them this is what problem you have, but to actually help treat that problem? So to basically look in more depth at the information that those medical records contain. And what deep learning is really doing is it's comparing that particular patient with, it's finding similarities between that patient and other patients it has in its database or its training data, and it's comparing them to successful treatments and what those treatments were from other patients. And by doing that, it can not only predict that you're at risk of an epileptic seizure, let's say, but it can actually discern what treatment would be more effective and advise a doctor on how they might best treat that patient. And so that's a whole new world, and it's definitely coming. These are very, very exciting and powerful applications of deep learning in medicine.
Andy, in all three examples that you've given, you've used the phrase, one thing I'm really excited about is. Why is being excited about a subject important to you?
I guess I'm excited for a number of reasons, and that's a great question. But I think for me, the reason that I get excited about an application is there's a technical side. So as a physicist, I'm really thrilled every day to get up and be working on these amazing algorithms that can, like I said, solve problems that we never thought were solvable. But what I love is connecting that technology to the end application in some vertical. So I've spent significant parts of my career on teams building these industrial machines in factories, and I know what it would mean to those customers to make that machine better, and not only to those companies that make the machines, but to their customers. And so it's really enabling a technology that can improve, how we live in society. And so medicine, again, is another example. I love the algorithms, but the idea that you can now apply those and make healthcare better is amazing, that it passes through so clearly. There's such a clear line to the end application and the impact on people and society.
Is AI the province only of the largest companies, or does AI filter down? I mean, we all, with Alexa and with Siri, we take the benefit of AI. But in terms of smaller companies, can they harness the power of AI for themselves?
That's a great question. And it is challenging, and that's actually what led me to start my consulting company, Paradigm Shift AI, because it is a new technology. It's wonderful for companies like Google that have thousands of researchers doing AI, and they have 10 or 20 years experience, and they can get the best people. But it's challenging if you're a smaller company and you're asking yourself, how could I get started in AI? There's sort of two problems that they face if you generalize it, which is one, piercing the veil of all the buzzwords, trying to understand how all these moving parts fit together, what's machine learning, what's deep learning, and things like, what sort of applications could I do? Once I've decided on that, what algorithm should I use? What would be biting off more than I can chew versus what is sort of feasible to get started? And so all those questions, some of them are strategy questions, and some of them are simply technical. And at the end, you end up with an application that you want to try to do. And then it's very hard to get talent because there's really a supply-demand imbalance of people that know how to do this work. And so the reason I started my company is to provide a resource both for that early sort of strategy formation phase, and then also for the ability for companies to outsource the finding and hiring of technical talent and to get started in AI. And maybe they want to eventually build their own internal team, or maybe they're happy to have customized engineering work done to create applications that we help them decide on, we can decide together. And so that's an interesting challenge, and we're trying to address that.
That is very cool. For people who want more information about what you and your company can do for them, where can they go on the web?
Our website isn't quite up yet. It'll be up in about a month. When it is, they can go to www.paradigmshift.ai. That
website is all one word, paradigmshift.ai, PARADIGMSHIFT, paradigmshift.ai. And Andy Steinbach is a physicist who's been studying AI. And Andy, thanks for joining us today.
You're welcome, Larry.
I want to introduce you to a new website, Thalo.com. Thalo is an artist community and networking site for creative people to connect, be inspired, and showcase their creativity. Thalo.com features content from around the world with a global perspective on all things creative. Thalo is the place for creative folks to learn, collaborate, market, and sell their works. Thalo is a part of Thalo Arts, a worldwide community of artists, filmmakers, and storytellers. From photography to filmmaking, performing arts to fine arts, and everything in between, Thalo is filled with the resources you need to succeed. Visit Thalo.com and discover how their community can help you connect, learn, and succeed. That's Thalo.com. Sam Bogoch is the CEO of Axle.ai, which has developed a new, approachable system for asset management, also called Axle.ai, which prominently features, not surprisingly, AI as part of its technology. Hello, Sam. Welcome back.
Thanks much. Great to be with you.
Sam, before we start talking about artificial intelligence itself, tell us about Axle. What does your product do?
It basically scans the contents of folks' storage, usually containing lots of video, because that's our intended customer base. And we have over 500 customers today from a number of different walks of life. And basically, it scans their storage, makes low-res versions of all the media that it finds, and then dispatches those to be analyzed by one or more AI engines. Some are on board, built into the software, and others are outboard, as in the case of, say, Microsoft's video indexer product. We're starting to work with a growing list of vendors because the space is getting very diverse and very competitive in terms of who can analyze things the best.
Well, this is an interesting concept that I hadn't considered before. AI is sort of a description of machine learning and deep learning, but you're implying that there's different products that do AI, meaning there's different functions within it. How does Axle use AI, and what do you mean by different engines?
To give a short list of the possibilities, there are already AI engines on the market that will do things like transcription, right? Speech to text, where you can just take the soundtrack of something and spit out text of what the person or people said. There's facial recognition, where you can actually identify who was in the video, especially if they're celebrities or public figures. There's object recognition, where you can pick up, that's a chair, that's a door, it's a car, etc. And then there's things like brands, so you can pick up brands when they appear on screen. You can do OCR, optical character recognition, where, for instance, if it's a player and he's wearing number 45 will show up in the metadata. And there's even things like, emotional analysis. You can tell if the scene involves people getting very excited or happy or sad. That is actually just a short list of what's available right now, because the options are proliferating, and video is getting a whole lot easier to analyze as a result.
How does it work? Not in terms of how does the AI recognize the characters, because I think that's too deep, but in terms of my operation, how do I get it to determine who the people are in a video or the speech to text? What do I need to do?
Well, with our software, we're trying to simplify it so that you basically need to just let the software loose on your storage. It scans all the videos and makes low-res versions. And then you can pick from a menu, say, I want all the videos in this folder to get sent off and analyzed for transcription. Or I want all the videos in this other folder to get sent off to identify the faces that are in the video. And so we give you literally a pull-down menu. You send these things off to the right engines. In some cases, like with object recognition, we're able to do that on board in our software without any external fees. In other cases, there are cloud vendors, for instance, that will let you do a few hundred hours a month for free, and then above that, they charge you a certain amount per hour, typically anywhere in the range from $4 to $10 an hour, but occasionally more than that.
Why did you decide to implement this? Because Axle was doing fine on its own. Why the shift into AI?
Fundamentally, media management is a chore. It's something that's done way too seldom because nobody wants to do it. And in the past, it required a whole bunch of interns or a bunch of time that people didn't have. And this is even in big famous broadcasters who will go nameless. But I've met with some of these folks, and you would think they would have their act together and everything would be cataloged, but they literally don't have the time. So it occurred to us that with the advent of AI, you really can change that, and you can make media management and searchability the core of your work because it can be done automatically. And just to compound that, because of the way video is being watched today, which is in all these bite-sized flavors, whether it's on mobile devices or on laptop screens or on iPads, across that spectrum, the video needs to be sliced up into small enough chunks that it's actually critical to have all the descriptive metadata. But back in the day when you would just watch the primetime TV shows, you just needed to know the name of your show, and you'd sit down at 8:30 or whatever and watch it for a half hour, and you'd be happy. But now everyone wants to, it's like, I want to find the part of Walking Dead where he tells that story about and they want to go directly to the 10-minute clip that they want to see. That's only possible if you have all the descriptive metadata in there with the clips.
Now, what does descriptive metadata mean to you?
It basically means some combination of the stuff I was talking about, the transcript, who's in the frame, what's in the frame. And then there's also stuff that you don't need AI for, like the name of the episode, the name of the series, what aspect ratio it was shot in, the duration of the clip, all of these things. So all of that, if you add all that up, that's basically the metadata.
So do you see this as an enhancement to the editor's role or a replacement for some of the work the editor used to do?
As it stands right now, the role of the craft editor is not going away, right? People need shows to look good, and fortunately, at the moment, the only good way to do that is with editors. I will say that a lot of the routine editing of like splicing together back-to-back highlights, let's say, or putting together simple sizzle reels. I mean, something where like someone just wants to see a bunch of stuff back-to-back. There's evidence that AI can start to do those things, but anything that requires judgment is going to continue to be a person is going to be required in the loop.
Thinking about the problem we've got where we barely have enough room to store the stuff we've got already, as we start to shift into AI, do these additional files take tons of storage space?
They actually take relatively little space compared to the video itself, because video is already so huge, especially nowadays when it's being shot in 4K or 8K. Typically, you might have hundreds of gigabytes of video, but only hundreds of megabytes of metadata to go with it. So it's usually quite a bit smaller than the video itself. And because it makes that video so much more searchable and valuable, it's well worth carrying around.
Do we need to change the way that we operate to be able to leverage our metadata more? Metadata, by the way, is simply labels for a portion or all of our media.
Exactly.
Do we need to retrain ourselves to use metadata?
I would say so, and I would argue that the good editors were always doing stuff like this. They might have been putting it as comments in the timeline or doing some logging when the stuff was first ingested. Nobody likes to rummage, right? If you're working on a feature-length film and there was a ton of footage shot to make up that movie, nobody wants to be the guy who's just rummaging through all that footage to find the right part. So all this is really an extension of best practices that were already followed, I would say, by the most efficient folks in the industry. And the other thing that is changing, though, is that the mode of storage is shifting, because you generally can't do this if your drives are just sitting around loose on the shelf, right? To catalog all the material, it probably needs to be organized in a central folder structure. Our recommendation is you buy some kind of shared storage, but the cost of that is coming way down. And then once you have all the material on a storage pool of some kind, then you can start, clicking on different AI engines to analyze it and enrich it.
So in other words, we got to move the media that we would normally have on direct attached RAIDs and put it up to a server so that the server can then be accessed by Axle and dealt with in the background while we're busy doing other stuff in the foreground.
I think that's right. And that's obviously true not only of Axle, but really of any kind of logical system that's going to do this stuff. There are ways you could catalog individual drives and put them back on the shelf, but then the minute you need something, you'll be going back to the shelf to get the drive, and that could get pretty tiring. So, back when shared storage was really expensive and required fiber and a SAN and cost hundreds of thousands of dollars, there were lots of good reasons why small teams wouldn't want to do it. But nowadays, you can get a very powerful but inexpensive NAS, put a few 8 or 12 terabyte hard drives in there, and have a very powerful system for not a lot of money.
One of the new products you released is a product called Connector. What's the advantage of Connector if we look at it in terms of AI?
The big thing is that once people have more metadata and they have a better global view of their media, it's only natural that they'd want to do stuff with it. And Connector makes it possible to visually hook up connected workflows where you might say, publish something to Vimeo, send somebody an email, FTP something, these different steps. Transcoding is another example. In the past, these were very arduous to do because you would have to just rinse and repeat manually. And Connector makes it very easy visually to build automatic versions of those workflows.
Sam, for people that want to learn more about the work that Axle.ai can do for them, where can they go on the web?
www.axle.ai.
And Sam Bogoch is the CEO of Axle.ai. And Sam, thanks for joining us this week.
Thank you.
You know, I was just thinking, in 1966, the National Commission on Technology, Automation, and Economic Progress wrote in its final report, quote, "The basic fact is that technology eliminates jobs, not work," close quote. The technological shifts caused by AI are unstoppable and have been equated to the changes created by the Industrial Revolution more than a century ago. In January of this year, the Harvard Business Review wrote, quote, "Humans have always shifted away from work suitable for machines into other jobs. This is true in the 1930s when the shift was away from agriculture, through the 1990s and early 2000s when the shift was largely out of manufacturing. The challenges of automation extend far beyond media into a discussion of education, public policy, and society. Returning to that 1966 final report of the National Commission on Technology, they wrote, quote, "Constant job displacement is the price of a dynamic economy. History suggests that it is a price worth paying, but the accompanying burdens and benefits should be distributed fairly, and this has not always been the case." As the Harvard Business Review continued, quote, "Policymakers should focus on cushioning the necessary transitions following job loss by strengthening the social safety net, such as unemployment insurance, Medicaid, and a wage insurance program for all displaced workers to help encourage people to remain attached to the labor force." The challenges automation presents media creators are, as with most new technology, a two-edged sword. The benefits are that we can work faster or better or accomplish tasks that we could never do before. The trade-off is that in many cases there will be fewer of us doing it, with a resulting decrease in budgets. We can't stop this change, but we can start preparing ourselves and our companies for this change by continuing our education, strengthening our client relationships, and helping clients understand how to take advantage of all this new technology. Hiding our heads in the sand won't make the problem go away. The Digital Production Buzz concentrates on media, but that doesn't mean we're ignoring the changes going on in the greater society. Just something I'm thinking about. I want to thank our guests this week, Phillip Hodgetts with Lumberjack System, Andy Steinbach with Paradigm Shift AI, Sam Bogoch with Axle.ai, and James DeRuvo with doddleNEWS.com. There's a lot of history in our industry, and it's all posted to our website at digitalproductionbuzz.com. Here you'll find thousands of interviews, all online and all available to you today. And remember to sign up for our free weekly show newsletter that comes out every Saturday. Talk with us on Twitter at DPBuzz and Facebook at digitalproductionbuzz.com. Our theme music is composed by Nathan Doogie Turner, with additional music provided by smartsound.com. Our producer is Debbie Price. My name is Larry Jordan, and thanks for listening to the Digital Production Buzz. The Digital Production Buzz is copyright 2018 by Thalo LLC.